is a presentation by ABBYY entitled Digital Transformation and PDF, why OCR is not only for capturing paper documents. You can download our presentation in handouts section. Please feel free to download it. I'm Koltsova, Director of Product Marketing for Mobile and Fine Reader in the ABBYY Consumer Apps Group. The topic of this presentation is how OCR technology facilitates digital transformation for PDF documents. Then I'll add a few words about ABBYY's PDF solution, FineReader PDF 15, which makes it real for millions of users in the world. Facilitating digital transformation for PDFs by OCR may sound unusual at first. OCR has been around for quite a long time, and everybody knows what it is for. Isn't it something to digitize paper documents? And PDFs are already digital, right? That's right, but they aren't that simple. And today I would like to demonstrate you that OCR does much more than just digitizing old papers. It is the thing that allows us to work with PDFs effectively. Why do we need to digitize PDFs with OCR? They are already inside the computer in digital, aren't they? The answer is that while most of the PDFs are perfectly well to be nicely displayed on the screen, we need to know PDF document structure to analyze, modify, and reuse them effectively. Let's have a look what we have in PDF of different types. In scanned or image-only PDFs, we have only a picture. There's no text inside to work with, and we don't know anything about the structure from the PDF itself. In searchable and so-called digital-born PDFs, we usually have usable text of the document inside the file, but still there's nothing in it about the document structure. PDFs do not contain information about the document structure. From a PDF itself, we don't know what the parts of the text, images, lines, and other elements are. We don't know what the role of each of those elements is and how they are related to each other. This is what OCR can help to figure out. Well, some types of PDFs, such as PDF UA, may contain additional information that describes the structure to some extent. But those are just a small number of all PDFs, and it still would not be enough to analyze and modify PDFs effectively, which is necessary for many operations we want to do with PDFs. What kind of operation I'm talking about? Those are many PDFs that go beyond just working with a PDF document as a whole or set of pages, such as displaying a PDF on the screen, page manipulations, commenting, adding stamps, or digital signature. I'm speaking about such operations as text editing, full text search, reduction, extracting tables, comparing documents, and so on, which you can see in the list. For some of them, it's quite clear why and how they depend on OCR, such as operation with scanned PDFs. But for the others, such as the operations with digital PDFs, it isn't that obvious. Further in the presentation, we will take a closer look at 3 of such functions. But before that, let's have a simplified overview of how OCR works to clarify what kind of useful information about a document it can provide. There are 3 major steps in OCR process. Firstly, the document pages must be analyzed. The system that does that is called document analysis, or just DA. DA is almost literally looks at each page and analyzes its image starting from its general appearance and going further down to detect the smallest parts of the image that would be separate words or characters. This way, DA finds which parts of the page contains text, which are the picture, which are the tables, and if there are background pictures on the page. Barcodes are detected too. Also, DA analyzes the tables to find out which parts of the table image are separators, which are the cells, and what's inside each cell. The second step is to recognize each bit of text found by DA. This is done by the OCR, Optical Character Recognition System itself. OCR reads images of each character or character combination, giving us the digital text to work with further in the form of computer codes. On the third stage, the synthesis systems comes into play. By now, we have information about where the text, pictures, and tables are in the page, where are the table cells and separators, and which character sequences are there in every text piece and table cell. We also know from DA such things as separation of the image into lines and words and where they are on the page. We have all the pieces, but we don't have the building yet. And it's the task for the synthesis system. It basically assembles the whole document in a digital form from all its pieces. It analyzes the parameters and order, looks for specific patterns and similarities on a page and between the pages, and many other things to recreate the document structure. On this stage, we finally get information about such things as roles of the text pieces, a paragraph, a heading, a header, footer, a list, and so on. Where to place all these pieces in the digital document, what shall be each paragraph or even a part of a paragraph formatting, character and line spacing, indentations, alignment, and so on. Now we have a digital representation of a PDF document structure. We know enough to analyze, compare, modify, or extract its content effectively. Now, let's have a look how this knowledge allows to solve some specific PDF-related tasks. We'll start with editing text paragraph in a PDF document. Well, what's the deal exactly with editing a digital PDF? An average PDF user probably expects that there is text and everything else in digital PDFs, so it shouldn't be any problem to edit them. It must not be any harder than editing a Word document. We wish it were true. PDF reality is unfortunately different. The format was not created with editability in mind. Rather otherwise. It's not really editable by design. As it was mentioned earlier, PDF contains only information about separate characters. There's no information about words, lines, paragraphs, and other document elements. There's no information about the document structure that could be followed when adding or deleting some text. Simply adding or deleting characters could be possible probably, but it wouldn't change the way how and where the surrounding structurally connected characters are displayed. Look at the picture. That is how it could look like if we were simply interesting or deleting characters in a PDF. To sum up, the deal is that there is no information in a PDF about how to rearrange other elements when adding or deleting some. And to keep a paragraph of text consistent when editing it, we do need this information. The idea of how to edit a paragraph in a digital PDF is quite simple. The text is taken from the PDF as it's already there. The markup, which we need to know and follow in order to edit the whole paragraph properly, is detected by OCR. The OCR involvement in the PDF paragraph level editing process looks like this. First, once a user initiates editing, The document analysis processes raster image of the page and finds the elements such as text and pictures. Then synthesis systems creates a temporary copy of the page with all necessary markup added. Digital text taken from the PDF itself is aligned with the detected structure, which combination allows the page to be edited by the user. Then the user edits, and since the program already knows and can now follow the structure of paragraphs, the text is edited smoothly. It reflows from line to line and character spacing is followed, the font is selected automatically, paragraph borders can expand or shrink according to the edits, and so on. All the edits are displayed to the user in real time. Once editing is done, the PDF is updated only in the part that has been changed. Despite of using OCR, the editing does not require creation of the resulting document as a copy of the original one made by conversation process. As the edits are done in the original document itself, everything that hasn't been edited is preserved as is. OCR also helps to effectively reuse tables by extracting them directly from PDFs. Let's take a closer look. Tables looks really well in a digital PDFs. We can easily select text in any cell and copy it elsewhere. It's really tempting to be able to just get what we can see quickly and easily and copy the whole table just by selecting it. But can we? Unfortunately not. Selecting the whole table in a digital PDF in the usual way, as we do with text, will help no more than for copying the text itself. All the table structure will be completely lost, and you have to recreate it from scratch. Why does it happen this way? In a digital PDF, visual appearance of a table is defined by a set of objects, such as lines and rectangles, which are there completely on their own. Just separate objects described in terms how they shall look like, but not described what are they, how they relate to each other, and to the content of the table. The table content structure isn't described either. It's not known which table cell each piece of the text belongs, and whether it belongs to the table at all. Okay, once those lines and rectangles are already in the PDF, why not to copy and paste? If we did that, in the best case we could probably paste what we copied only into another PDF. Even so, the success would be questionable, and no way we could paste what we copied into any other application, such as Microsoft Word or Excel, for example. But there is a solution. If we can, so to say, read about the table from a PDF, since tables aren't described even in a digital-born PDFs, let's see it. OCR can describe and recreate structure of a table based on its image. With the help of OCR, a table can be extracted in its rasterized entirety. That's how it works. Firstly, the selected area with the table is turned into image. Then the image is analyzed by document analysis, which finds the table elements, cells, separators, backgrounds, text, and picture elements in the cell. Then we need the text itself. If the PDF text is good, it is taken from the PDF. If not, the text can be also OCR'd from image. Synthesis system then assembles the detected structure and the content into a properly marked up piece. It's placed into the clipboard, and the user can paste it as a whole table into any Office application, such as Excel, Word, an email program, and so on. The third case for today is when OCR helps to compare digital PDFs more accurately. When it comes to comparing digital PDFs, once again one may ask, we have all the characters inside the PDF. What else do we need to have the PDFs compared successfully? Let's clarify that. In general, when comparing two copies of a document in any format, not only PDF, one of the goals is to minimize false differences. The other one is not to miss any of the actual differences between the two texts. Main causes for false difference can be three. The first is when in the two copies the same text is formatted in a different way or placed somewhat differently within the page, but the overall order of how the text appears in the document is not changed. The second is when the main text is broken by header, footer, or an insert in different places. Both situations may be results of edits made in the text of one of the copy or changes made to the layout, such as setting the margins differently, for example. For both situations, the solution to avoid false differences would be, as you probably already guessed, to have and use information about the document structure. That is, to apply OCR to recreate it. However, there is also the third reason for possible false differences, and that is OCR accuracy, which is, generally speaking, is not 100%. A kind of contradiction here, and we will return to it a bit later. Here is a sample how the false differences appear due to lack of information about document structure. In the part of the document on the screenshot, there is only one real difference. In the copy on the left, there is a footer, while in the one on the right there isn't. The other text is the same, although it is distributed between the pages differently, as you can see. Look at the beginning of the section 4 in both copies. Here, the same pair of the documents, the same place, compared without taking care of the document structure. As you may see, for just one real difference, as many as 4 extra false differences are created. False differences are unnecessary and unwanted points of attention for the user, which makes them to spend more time to analyze and eventually get tired, decreasing level of attention and overall productivity. That's why we want to minimize them. So if we just take the text from a digital PDF and use it for comparison, we risk creating a lot of false differences because we didn't and couldn't take into consideration document structure and understand that the text may flow from page to page differently, may be broken down by headers and footers, which do not belong to the main text, and so on. Another potential problem with just taking the text from a PDF, which I haven't yet mentioned, but it is there. The text layer in a PDF is not always accurate or usable. We clarified that to compare digital PDFs accurately, it's a good idea to use OCR to know the document structure, and at the same time, it's better not to use the OCR due to possible false differences introduced by it. However, in case there are problems with the text layer quality, it's better to use OCR. Is there any good solution for that? Sure, there is. We shall use OCR intelligently. Let's minimize utilization of character recognition by taking as much of the text from the PDF as possible in a digital, while using enough information about the document structure to correctly identify what exactly and in which order shall be compared. How the comparison works in case of digital PDFs. First, they are prepared, rasterized, and pre-recognized. Then, document analysis and synthesis system defines the document structure, finding such elements as a paragraph, lists, inserts, headers and footers, page numbering, and so on. Then, quality of the text layer is assessed. That's the reason, by the way, why preliminary recognition is required on the first stage of preparation. Valid parts of the text are taken for comparison directly from the PDF. The bad parts are recognized. And after that, when paragraphs, headers, inserts from the two copies are properly aligned, the comparison itself happens. And even if they didn't pixel much, or even were shifted in the two copies being compared, they can now be compared properly. Now, to demonstrate you in action the three OCR-powered PDF features considered in the presentation, I'd like to show you a short clip recorded from ABBYY FineReader PDF 15. I hope everyone can see my screen. So the first is multi-line paragraph level PDF page editing. It is a digital PDF being edited here. When a user clicks the edit button, the page is being prepared for editing by document analysis and synthesis system. Once it's done, the user can start editing. You can see how OCR support allows not only to get a smooth and correct text flow from line to line while you are editing the text, but also to be able even to edit the page layout by rearranging paragraphs and pictures. By the way, scanned PDFs can be edited exactly the same way too. The second part shows how to copy a table from a PDF in just a few clicks. As you can see, it takes just to select the table area and click Copy as a Table. Copy as a Table button that appears. OCR does its job on recreating the table structure and formatting based on its image. The text is taken and the table can now be simply pasted to Excel. Now it is possible to get straight to working with this data. Edit, do calculations, check for validity, and so on. The third part of the demo is comparing PDF documents. We have a digital PDF here, but as you may see, there is a problem with the digital text in it. When you try to copy it, it turns out it's broken. It could be the result of a problem with encoding when the document was created. Now it's going to be compared with another copy of this document, which has a few differences in the text. Once both copies are prepared for comparison, that is rasterized and pre-recognized, the user hits Compare button and the comparison starts. FineReader PDF detects the problem with the text layer, OCRs the document. In this case, it takes a bit more time than just taking a valid digital text from a PDF. As a result, FineReader successfully finds all the difference between these two copies of the document. Okay, let's get back to our presentation. So at the end of my presentation, I'd like to briefly tell you about FineReader PDF 15. As you could see, FineReader PDF 15 is intensively OCR-powered PDF software, which gives it some unique capabilities and provides benefits to its users. Conversion is a very important function for many users, and ABBYY's AI-based OCR technology ensures FineReader users excellent document conversion results. FineReader PDF is very easy to use for working with any kind of PDFs, including scanned ones, thanks to background recognition feature, which automatically makes content of any PDF readily available for the user once it's opened. Accurate and powerful recreation of the document structure and layout not only allows high-quality conversion, but also further facilitates using of many of the PDF features and improves their quality. FineReader PDF users highly prizes its capabilities. Here's what a user, which is a consultant in IT solution provider for agriculture industry, says about working with tables in PDF documents. We receive price lists in PDF format, which we formerly had to copy and paste pieces of information into Excel. One price list took 2 of us at least a day and a half to process the data to Excel. With ABBYY FineReader, we were able to convert the same document to Excel in under 5 minutes. Another FineReader PDF user, a college professor, says about making information in PDF document accessible for students and educators. PDF documents sometimes pose challenges. FineReader is my go-to tool for generating a searchable, accessible, or alternative format. My favorite feature in FineReader offers is the ability to convert an inaccessible PDF into universally accessible document or PDF UA. FineReader product family consists of 3 main products: ABBYY FineReader PDF Standard, individual productivity tool for daily work with PDFs, document collaboration, conversion, and content reusing tasks. ABBYY FineReader PDF Corporate, a workgroup PDF productivity solution, which additionally offers cross-format document comparison and personal conversion automation and scheduling tools. ABBYY FineReader Server, a high-volume server-based document conversion solution for solving organization-wide tasks in a centralized, highly automated manner. At the end of the presentation, I would like to offer you a promo code for FineReader Corporate. The name of promo code OctoberPDFest 20. It gives 20% discount and it's valid until the end of this year. You can get the product by the link pdf.abby.com. This concludes my presentation. Thank you very much for your attention. Feel free to get in touch with me by email or via LinkedIn. My contact details you can see on the slide. Now, if you have any question, I and my colleagues, who are also here on this presentation, would be glad to answer.
Thank you, Anna. Yes, and we'd love to take your questions now for the team from ABBYY. So feel free to put questions into the questions pane. That'll be great.
Yes, hello, it's Yuri speaking. So yeah, we have several questions already now. So let me read the most interesting of them and we'll answer them. Okay, so the first question was, can scanned PDFs be edited the same way as the digital ones? Yes, so basically, scanned PDFs, image PDFs are are edited by FineReader the same way, using the same approaches with OCR. But obviously, when we have only an image in a PDF, all the text is taken from the results of OCR work. We don't have any digital text inside to take it from PDF directly. Another question, how FineReader understands text formatting like font, color, and so on while editing text if there is no such information in PDF? Basically, it's all these characteristics of the text in a PDF text formatting are defined by the OCR system. Document analysis and most important, the document synthesis system define all the characteristics of the text for different pieces and use the suitable font size, color, and so on when a user is doing his or her edits into a PDF document. Then we have a question about comparison. Which languages can FineReader use in comparison feature? Can it compare documents in Polish, Czech, and Russian? Yes, it can compare in those languages. In general, FineReader supports now 40 different comparison of documents in 40 different languages. Yeah, most of European ones and some others too. Okay, the next question was, you told about comparing digital PDFs. Is it possible to compare scanned PDFs or images of documents? Yes, FineReader can understand the structure, all the necessary information about the document, all the necessary information to compare them about from any kind of PDF, from digital PDFs, from scanned PDFs, and other images of documents. So it can compare all those types of documents, also compare them between two copies in one of these types in different kind of PDFs, for example. It can compare also a PDF to a purely digital document, I mean, like Office document like Word, Excel, or ODT document, or any other, or some other text-based formats. So basically, it's done pretty much the same way. Okay. And another question we have: should I convert the whole document to Excel to copy a table from a PDF? No, actually, as you might see in this recorded demonstration from the product, if you have a PDF with a table and you need only this table from a PDF, you don't need to convert the whole document. You just need to select this table when you are viewing a PDF in FineReader and click a button copy as table, and then just this table will be converted into a pure table format and that you can paste into Excel.
Yuri, sorry for interrupting, but Duff noticed that we are out of time.
Sure. I believe that was the last question.
I think there actually was one other. Is there a FineReader mobile application for scanning an OCR? I see one other question here.
Yeah, we have a type of FineReader app on mobile, iOS and Android. Right now it's called FineScanner, and it allows to create scanned copies of paper documents as you do with a traditional desktop scanner. It allows to OCR the document, made some basic PDF manipulations, and soon it will join FineReader family and will get new name FineReader.